All right, I want to go through an example where we work out completely a reduced row echelon form matrix. So here we have a system of equations that we want to solve. So let's begin by turning it into an augmented matrix here. Okay, so here we go. There is a nice augmented matrix for this system. Now, the way I'm going to go through this is just sort of telling you the steps we want to do, and then I'll write down what the steps are, but I'm not going to actually compute the arithmetic just to save some time here. So, the very first thing when we're trying to do this Gauss-Jordan elimination process to put something into reduced row echelon form is this number up here, this top left number, needs to be a 1. Now we can do whatever we want to make this into a 1. We could take this row and divide it by 2. That would perfectly work. You usually want to think of, what's the smartest way to do it. You could do row 2 minus row 1 and put that in row 1. That'll do it. There's really all kinds of options for us. But if we look at this column, we already have a 1 down here at the bottom. So our easiest choice is really just going to be row 1 switch with row 3. Right? So let's go ahead and do that. So we'll get 1 minus 3, 2, 0. Row 2 stays the same. And our former row 1 goes down to the bottom. So now we have that 1 in the top left. That should always be the first goal. Once we have that, remember, one of the rules for reduced row echelon form is if you have a leading 1, which this right here is a leading 1 for the first row, everything else in the column needs to be a 0. Sorry, here, maybe I should say make this 1. These two numbers right here, we want to make 0. Right? How can we do that? Well, usually the way we do this is, since we have the leading 1 here, we're just going to use row 1 to knock out these ones. So if we do something like row 2 minus 3 row 1s, that's going to give us 3 minus 3 times this, so that'll knock this out. Right? This is why we always find the leading 1s first. Right? Now I'm going to kind of combine some steps here, just to make this quicker. To get rid of this 2, we're going to do row 3 minus 2 row 1 goes to row 3. Okay? If we do that, these two numbers here become 0. Now, whatever happens to the rest of this doesn't matter too much. The point is, these become 0. So, once we do these steps, what we're going to wind up with is 1, negative 3, 2, 0. Let's see. We'll get 0, 10, negative 7, and 7. 0, 4, negative 3, 3. So now we're here. Okay. Now what we want to do, the way to figure out the next step here, is basically say, well, this first column is done. So in our mind, we're going to ignore that first column now. And as far as the next step goes, what we want to do is sort of ignore that top row for the moment, right? And we're going to say, all right, in this new matrix I've made here, can I get a 1 in this top left corner? In this case, we can. We absolutely can do it. So let's do it. So how do we do it here? Well, there's not really a great option. So we can always do it sort of the brute force way, which is to just take this row 2, right? And, well, there's a 10 there, so let's divide it by 10. Right? And replace row 2 with that. If we do that, 1, -3, 2, right? We get 0, 1. This is now minus 7 over 10 and 7 over 10. 0, 4, minus 3, 3. Okay. Now, one thing I really want to emphasize for you guys here is don't be afraid of fractions here, right? You're typically going to get them. So again, the step we did here is we made this a 1. Okay, so definitely don't be afraid of them. So now that we got this 1, now notice again, this is the first leading one. If we go down to the next row, remember that the leading one has to be to the right, and that's where it is. Right? It could be here or here. It really depends on what matrix we're looking at, but it can't be here. We got this, we're good. Right? Now that means the next step is we want to make these 0. Right? Because again, once we get our leading 1, everything else in the column has to be made into 0. So, how do we do that? Well, this time, right, to get the zeros in that column, you always want to use your leading 1 to do it. Now, why do you want to always use your leading 1? The important reason for that is so this column doesn't change. Right? It's very important that this column does not change. So we're always going to use row 2 to change these other ones here. So here we can do row 1 plus 3 row 2 goes to row 1. And we can do row 3 minus 4 row 2 goes to row 3. So again, I'm going to leave the arithmetic for you to double check here. Okay. So the first column is still 1, 0, 0. The next column is going to be 0, 1, 0. Here we got minus 7 tenths. 7 tenths. All right, what we're going to end up with after that procedure is negative 1/10, 21 over 10. Here this is going to be negative 2 over 10 and 2 over 10. Okay. All right. So now our first 2 columns are done. So we're going to mentally set them aside. And since we set aside these 2 columns, or since we have the leading ones in these 2 rows, we're going to ignore the first 2 rows here. And now that means whatever's left down here in the bottom right, this, we need to make 0. Oh, sorry, make 1. Make a 1. This, right? If this is a 0, then there's nothing left we could do, right? But this isn't 0, so we can make it into another leading 1. What do we have to do here? Well, there's a negative 2 over 10 there. So if we multiply by negative 10 over 2, right, that's going to turn it into a nice, lovely 1. Go ahead and do that. We get 1, 0, 0, 0, 1, 0, minus 1 over 10, minus 7 over 10, 10, 7 over 10, and negative. Fantastic. Okay. Now that we have that, we have our leading 1 here. So what do? just like we did before, after we got that leading 1, we want to make everything else into 0. Make zeros here. Right? So, how do we do that? Well, we're going to use row 3 to change it. So if we do row 1, plus 1/10 of row 3, place row 1 with that. Here we're going to do row 2 plus 7/10. Row 3 goes to row 2. Oh, row 2. Right, and that'll zero those out for us. Okay, and again, I'm going to let you check the arithmetic here. But this should turn this matrix into a very nice matrix of zeros and ones. And the constants actually wind up working out beautifully here into 2, 0, 1. Okay. Now we switch this back to a system of equations. The first equation says that x1 equals 2. Second one says x2 is 0. Third one says x3, 1. Right, and that's that. So our solution, right, this is one way of writing it. Another way of writing it that I really like to encourage. So that's how that works out there. Right. I want to show off this process at least one more time. So let's do one more example here in this video. All right, let's say we have the system 2x1 minus 4x2 plus x3 equals -4. 4x1 minus 8x2 plus 7x3, 2, -2x1 plus 4x2 minus 3x3, 5. All right. So, with this, we're going to do the same thing that we've been doing. All right. So we're going to start out by switching this to an augmented matrix. And we're going to do the same things we always do here. All right. Now, in this case, there's no convenient 1 here for us. So we're going to have to just sort of eat this and divide by 2. Which again, no big deal. So 1/2 of row 1 goes to row 1. When we do that, we get our leading 1 that we want. Remember, this is still the first thing we want to change. We get our leading 1, -2, 1/2, -2. The rest of this just for now. And again, once we have our leading 1, we use it to zero out these things. This needs to be 1. These need to be 0. So we do row 2 minus 4, row 1, row 2, and row 3 plus 2, row 1. Okay. If we do this, then what happens? Get 1, -2, 1/2, 2. These are both 0. This next step here is going to work out that we get zeros here, 5, -2, 10, and 1. So we're going to apply the exact same procedure we did in the last problem. The first column is done, so let's block that off. Our first row has our leading 1, so let's block that off. Now we're going to look in what's sort of left over here. Ideally, this right here, we can make into a leading 1, right? However, if we look at this number right here, this is a 0. There's no way to turn that into a 1. This is a 0. There's also no way to turn that into a 1. Row 1 is stuck where it is. This has to stay here. We're only allowed to use rows 2 and 3 for this. So there's no way to make this into a 1. Right? It's very important here. There's no way to make this into a 1. Right? Since there's no way to do it because this entire column that's left over is zeros, what we do is say, well, okay, move the column over. That's it. That's all we do, is just move this over. And now we're going to write off that second column. And now again, we go to the top left corner and ask, can we make this into a 1? And yes, we absolutely can. We just divide by 5. 1/5 of row 2 goes to row 2. If we do that, we have 1, 0, 0, negative 2, 0, 0, 1/2, 1, negative 2, and negative 2, 2. Okay. Great. So we got our leading 1. And now these two we need to make into zeros. So do it. Right? For row 1 here, we could do row 1 minus 1/2 of row 2 goes to row 1. For row 3 here, we could do row 3 plus 2 row 2, row 3. Okay. And let's look at what we have. We'll get 1, 0, 0, negative 2, 0, 0, 0, 1, 0. Right here, let's see, we're going to get 2. This will be minus 3. And this one here will be 5. Right? Now, this row right here. If you ever have a row where all of these are 0, and this is not 0, if you ever have that, you're done. You don't have to do anymore. This always means no solution. Right? So if you ever have a row that has all zeros on the left, and specifically not a 0 on the right side, that means no solution. So I'll leave it here for this set of lectures. And hopefully this makes sense. Any questions, send them over as usual. And take care.